In my ongoing series to really max out what the Ender 5 is capable of, I've covered a lot of different components of the printer. Everything from the heated bed, the motion of the printer, and most recently the cooling. I've tackled most of the subsystems of this printer. One thing I haven't taken on though is what do I need to do to the printer if I want to print the more exotic filaments? Things like nylon, acrylic, polycarbonate. All of these different materials are going to require the hot end of the printer to get a lot hotter. And the default hot end isn't capable of it because it has a PTFE tube that goes way too close to the nozzle. Well, that's where a company called MicroSwiss comes in with their all-metal hot end. And thanks to them sending this over, we're finally going to tackle that on this printer, as well as a new nozzle from them, which I just recently picked up at the East Coast Rep Festival when I ran into them in person. So that's what we're doing today, right here on Cozy Fabrications. Let's get started. Hey, this is Editor Chris from the future, and I have to say, this video got way more in-depth and longer than I'd ever planned for it to be when I first started filming it. Because of that, I've decided to break it into some smaller videos so that it's easier for you to digest and honestly easier for me to edit. So in this video, I'm going to cover the hot end itself. I'm going to talk about why you need a metal hot end if you want to print the higher temperature filaments, what MicroSwiss has to offer. Then I'm also, of course, going to cover the installation and the changes to your slicer. So that's what you're going to get in this video. Stay tuned to the end of the video when I talk about what's coming up next. Thanks for watching. So to start off, let me explain how I'm going to kind of organize this video because I'm going to try to cover a lot of material in a short amount of time. So first of all, I'm going to start with the hot end itself. I'm going to talk about the components of a hot end and why you need to switch to an all-metal hot end in order to be able to print the more exotic high-temperature filaments. From there, I'm going to do the installation. We're going to make changes in your slicer that are needed for an all-metal hot end. Then we're going to do some test prints to compare to my sample prints that came from the before the change hot end. Then in part two, I'm going to cover nozzles. I'm going to talk about what nozzles are typically made of. I'm going to talk about what MicroSwiss's nozzles are made of, and then what their new nozzle they just released is made of and why it's important to your overall printing. Then we'll install this one, do the same sample print, see if we notice any noticeable difference, whether any of this is really improving the quality of your prints or just improving the longevity of your nozzles and the consistency of your prints over time. So from here, let's jump straight into the computer. I've got some stuff to show you on my screen because I think that's going to be the most efficient way to get through material and show you exactly what I'm talking about. So let's switch to the computer. So here we are on my desktop. As I mentioned, I'm going to basically share a lot of information with you this way. Why I chose to do it this way instead of a lot of on-screen graphics and stuff I had to generate is two reasons. One, let's be honest, this is a lot easier for me, less the stuff I have to generate. But this also shows you the source material. You can always go check any of these out at the top. You'll see the web addresses. I ended up starting to geek out on this material a lot. There's a lot of really cool material science here, particularly when you get into the different types of metals, their thermal conductivity, their hardness. And so I ended up with a lot of data here I wanted to move through quickly. And so, as you'll see, we'll go through the tabs. I'll explain it all to you. Hopefully, I'm going to give you a little bit more in this video than you typically see when you talk about all-metal hot ends. So if you're into the science of this or the engineering of this, hopefully you'll find this to be a little bit more informative than what you typically get. So right here on this screen, let's take a look at what MicroSwiss is offering. So this is the MicroSwiss hot end. You can see various images here of what it looks like installed, the components of the hot end, and everything you'll get in your package. Here's the price right here for you to take a look at. $63.50 is for this kit, which comes with everything you need to install it on a CR10 or an Ender printer. Comes with their standard brass nickel plated, it's a special nickel plating, we'll get into that, nozzle. And the $63.50, one of the questions I know a lot of people ask, why am I paying for the $63.50 for a MicroSwiss hot end instead of buying one that I may be able to get for $10 either on Amazon or on some of the overseas site? Well, I actually wanted to delve into that as well, and so I talked to MicroSwiss at the East Coast Rep Festival, And I found out that basically what you're getting here is they are basically hand manufacturing each of these themselves in their shop. These are not farmed out overseas. They are not farmed out even to another shop here in the US. They are actually being manufactured in-house in Minnesota at their offices. So what you're paying for is the scrutiny of each of these, that it is being milled to their specifications, and that you're getting a quality product every time. So what are you paying for? You're paying for engineering. You're paying for the care and the time that goes into producing a quality product. And that's important not only for the overall performance of the product, but when it comes to how do you want your 3D printer components manufactured. So moving on, let's take a look at the anatomy of a Hotend. So here's a standard Hotend. Here's the standard Hotend that you're going to be getting with your Creality printer. As I said, this is all the CR10 models. This is the Ender models. What you're getting is there's a PTF E-tube that is going to run all the way through your pneumatic coupler, which you should be familiar with, which is what you have to pull out if you change your nozzle and retighten. It's going to go through the heatsink, and then it's going to go into this. It's going to go into this heat break or throat of the nozzle right here, which in the stock heatsink is going to be made out of stainless steel. And then that goes all the way down to touch your nozzle right here. This is the heat block that actually heats everything up, and right here you're going to have your heater cartridge and thermistor that's reading your temperature, and obviously here's your nozzle. One note, if you ever have oozing of filament from your nozzle, most likely what's going on is right here in this area. These are not making direct contact, and so what happens is as this melts, as this becomes a liquid or a semi-liquid, it's going to leak out here and start coming through these threads because it's not tight. This is why anytime you change the nozzle, you should be pulling back your PTF E-tube, tightening your nozzle almost all the way, pushing your PTF E-tube down, and then tightening your nozzle the rest of the way to make this a liquid tight seal. Just a little side note that I thought people would be interested in. So what makes the all-metal Hotend different? So here's a micro Swiss Hotend, and you'll notice there's no PTF E-tube in any of this drawing. Why is that? Well, the PTF E-tube in this one, your pneumatic coupler is going to be up here, and your PTF E-tube is going to stop right here. Meaning your PTF E-tube at that point is only a guide. It's not actually holding any molten liquid or molten filament, I should say. And so there's nothing to leak. Your filament's going to go all the way through your heatsink, down into your heat break. This heat break is a titanium alloy. They claim it's almost 3 times lower thermal conductivity. That's probably about right. It's between 2 and 3 times less conductive because it's titanium than what you were going to get with stainless steel, which means that the heat that is being generated here, which is going to be much higher in these exotic filaments, is not going to be able to creep back up into this heat sink as well, making sure that hopefully your filament only stays molten in this area, which will prevent jams coming up into this part of the heat sink. So that's what you're getting in an all-metal Hotend, is this single line of filament that goes all the way from your PTFE tube, which stops early, and then goes straight from there through an all-metal shaft down into your nozzle. So going back to why are we paying for micro Swiss? Well, this machining is obviously going to become very important in the overall performance of this Hotend, because now, since the all-metal portion is from here all the way down to here, these components being machined accurately, smoothly, is even more important than it was in the stock Hotend, because if you had a PTF E-tube from here to here, then the only thing that has to be really machined well is your nozzle, which we've covered in previous videos. So now that I've covered why an all-metal Hotend, let's actually do the installation. I'm going to go through the whole process here. I'm not actually going to walk you through it though. Micro Swiss has a good tutorial on their website, as well as countless other YouTubers that have already covered this if you need some additional help. I'm obviously going to record myself doing it. I might have some little comments along the way, but let's get this thing apart and take a look at actually how it's done and what it looks like completed. Hey, Editor Chris here again, and I've got some bad news. The next section of video, I was using a new setup and a new camera that I hadn't used before, at least not in that situation. And unfortunately, I didn't notice this whole next section is in and out of focus a lot. The camera just could not focus on what I was doing, and I didn't notice it at the time. So I apologize to your eyes. Now, where possible, I did go in, I filmed some B-roll to put on top of it so that you could see what I was talking about, because I still want, if possible, for you to get a good, clear picture, particularly of the test prints. There are some parts of it, obviously, now that installation's done, I can't go back and refilm it easily. So, again, apologies. Hopefully the information is really good and that you can still enjoy that part of the video. One more thing. The test prints are all printed out of Filament 1 Traffic Red filament. I pulled this out of the package, out of my Filament 1 Profi box, and I absolutely fell in love with this color. That's why you're seeing it in this video. This is not sponsored by Filament 1. I purchased this myself, so I really hope you enjoy those prints. This stuff prints great. Head over to Filament 1, links in the description, if you like this Filament 2 and would like to get you a roll. Thanks for watching again. So before we go any further, I've done some pre-test printing, obviously, to make sure that we have a good baseline for what this default configuration can do before we go and change things. So for this, I've chosen 3 benchmarks. First up, we have our stock Benchy. So this is the Benchy everyone's come to know and love. As you can see, I actually replaced my P3D nozzle with a stock brass nozzle for this test. As you can see, quality is absolutely amazing on this. Everyone knows this benchmark pretty well. That's why I chose it. So you can see the only real noticeable defects on this one is there's some weird stringing down here I couldn't get rid of. I think it has to do with the slicer more than anything, because as you can see, there's no stringing here, no stringing here, nowhere where that you would normally see it. So it's really weird. Cura is doing something weird there for me. But as you see, layer consistency is excellent. Bottom layers look really good. These sort of notches are what you typically see from the slicer. So there it is. And of course, I also have my P3D nozzle showing pretty much the identical results to that. You can see nothing really noticeably different. Quality still excellent compared to the brass nozzle. This is their aluminum nozzle. High wear, excellent thermal transfer. See, looks great. For the second benchmark, I chose, let's make sure that we don't have any stringing problems with our default configuration. So we have our standard stringing test. This is the stock brass nozzle. You can see no stringing whatsoever. There's been no cleanup at all done on this. And looks beautiful. And same thing for the P3D nozzle. This is an aluminum nozzle. Absolutely no noticeable stringing. Beautiful prints there. And then, of course, I want kind of a real model. We want something that actually is going to show off quality, a lot of direction changes, overhangs, just a plethora of things that we care about when we look at prints. And so what I did, I went with this guy. So this is a Deadpool model. I'll share the link and artist for this model on the screen. And I chose this one actually for a very specific reason. Yes, it's a bust. Yes, it's similar to other busts, but what's great about this is a no support bust, meaning we have actual overhangs here, which as you can see, look excellent. There's a little bit of notice here that there's something going on, but overall, for something without supports, this is looking excellent. Nothing under this chin, looks great. I also chose this because it had these. With the katanas back here with no supports, this would be an excellent place to see stringing if that was going to happen. But as you see, there's no stringing at all on this. My settings are really dialed in for this configuration. You can see no problems. Looks great. Same thing with the one with my P3D nozzle. That last one was, of course, the brass nozzle. This is the P3D. As you can see, again, just minor layer overhang issues here. Nothing major for not having used supports. You can see layer consistency. Really, really nice. This is a 0.2 layer height. See a little bit of overhang issues here, but overall an excellent print. These are our benchmarks. This is what we're trying to get even as we change hot ends. So let's move on to what's in the Micro Swiss box. So here's the Micro Swiss container. I've already opened it, obviously, taking a look at what's in here. So you can see this is specifically the model for the Ender printers for the CR10s. Let's take a look. If you need a link to the installation instructions for your smart device, you can take a look at this CR code here. There's actually a URL here. What we have a new heating block, two nice screws there to hold in my heater cartridge. Standard everything. People have seen these before on almost any printer. Standard design. I have a new screw there, obviously, to hold in our thermistor. Here is the actual heatsink. And let me put this down so we can take a look at this real quick. And just so you know, I've got a sheet of paper down here on top of my glass hotbed where I can put all this so I'm not going to mess up my glass. Here we have probably the two most important parts of what you're purchasing here. So as you know, this is the actual heatsink, beautifully milled heatsink. All of the connectors really smooth. You can see here, this is where we're actually going to put in our Bowden tube, and hopefully you can see here, you can probably see the reflection in there. The Bowden tube is actually only going to go down to somewhere in this area, which means this whole section here is going to be heated, but there's not going to be a Bowden tube to, you know, help with any retraction issues. So we have to take that into account when we are setting that up in our slicer. See, very nice machined part here. This is the titanium heat break we were talking about. This is going to go into here. There's a grub screw right here that holds it in. So you can see, very tight heat break here, very small. The only thing is just big enough to let our filament through. And that, of course, plugs in directly to the heat block that we saw a minute ago. What else we got in here? Comes with our, these are the pieces that tighten up this when we put in our Bowden tube. Keeps everything snug. Make sure we don't have any, doesn't have any ability for the Bowden tube to move back and forward as it prints. It's really cool. I noticed these are actually 3D printed, so good on them for not actually having to mold those or anything like that. Have two new screws to attach it to the back plate here, as well as two grub screws, one for a backup, just like these. We're only going to need one of them, but it did come with two. Finally, in the box, we have a nice new silicone sock to cover up our heating block. We have the default nozzle that it comes with. Now, this isn't obviously just a standard brass nozzle. This is actually a brass coated in a proprietary coating that we're going to get to later. I'm not going to cover it here. But this coating here is a hardened coating. It will make this nozzle last longer than your standard brass nozzle. So this is also an upgrade. And last thing in the box, a tool. This is obviously going to be the right size for our thermal brake here. And it may even be the right size for the nozzles. There we go. That's everything in the package. Now, let's get started. I'm probably going to have to speed through some of this part because obviously I don't want to bore you with taking this all apart, but I'll comment where necessary. Loose enough to pull out? No. That's what I always worry about. See if I can push it from the other side. No. That is stuck in there, which is pretty common if you've been printing with one of these for a while. I'm going to pull this grub screw all the way out. There we go. Set that down someplace safe. Again, all of this coming off of here is hot. Alright, let's see if I can push on it from this side and get it to come out. Yeah, this is always a problem. This is real world here, guys. This is not a little tutorial video. No, that's not budging. This is heated. I'm wondering if we have thermal expansion going on here that's making it tight. So since everything is already out, we may have some thermal expansion issues. I'm going to go ahead and do a cool down on here. There we go. Maybe it cooled down enough. Alright, so that should have pulled both the thermistor and the hot end. Yeah, there was some gunk in there. That's what that is there. Finally burnt up. Real quick before we go any further, let's compare this one to the new one we're going to be using. Notice this one, the new one's just looks like about the same thickness and the same overall width, which is actually really nice, because what that means is that I don't have to worry about my nice cooling solution I've spent so long figuring out whether it's going to fit or not, because this and this are not geometrically the same, but dimensionally the same. So we're good there. Alright, moving right along. Now let's go ahead and attach this using the new ones. And notice the new screws we got are countersunk screws. That's why we're using those instead. And I'm using the same bit that I used before. I'm going to attach this one just a little bit. There we go. The nice thing about these countersunk ones is I was a little worried. So as you're starting to attach it, you're like, well, this is wiggly. Am I going to get it level? Am I going to get it in the right place? But since they're countersunk, it's going to push it right to where it's supposed to be. If I tighten these a little bit back and forth each way, they're going to end up right where they're supposed to be. There we go. That's tight. It's not wiggling at all. Okay. Here's the heat block. You'll notice this one, as opposed to the original one, this is the one I'm used to on some of the other printers I have. Instead of it being like this and the only thing holding it on is a grub screw, this one actually is a pressure fit clamp that is being held on with two different screws. This one's only being held on with that one grub screw. Alright, everything's done. Now let's head over to our slicer settings, make sure we have everything set up before we try to run a test print. So here I am in my slicing program. These are what I call my Ender 5 benchmark quality settings. What we usually care about when we go all metal is this retraction distance, which my default is 6 and 15. Obviously 15 is really slow. I've seen people bump this up to 25. That may work fine. I haven't tried 25. 15's been working great for me, so I haven't touched it. I wanted to see what the recommended settings were. So I had Micro Swiss send over one of their files. They sent over one for the Simplify 3D. So in this file, I was able to open it up with a text editor. Notice here are their retraction settings. Retraction distance they have is 4. And if you look at the speed, it's set to 2400. 2400 being millimeters per minute. If we divide that by 60, we get 40 millimeters per second. So I could try with my default settings. There'd be nothing wrong with that. But the first thing I want to do, let's try with their recommended settings. Obviously, they've tested this out. They've tested this out for a CR10. Very similar setup to any of the Ender printers. So I'm going to go in here. I'm going to change my retraction distance to 4. My retraction speed to 40. And the first thing I want to print, this is my simplest of my test prints. So I'm going to try and print this stringing test first and see how it does. I'm going to hit prepare. All right, it says it's only going to take 14 minutes to print. We're going to test that. So one thing I didn't mention to begin with. What we want is to make sure that our new all-metal Hotend can print just as well as we were able to with the stock one. We don't want a specialized Hotend for the exotic filament and then a different Hotend for the standard PLA. So what I want to do before we ever try to print the nylons and stuff like that, what I want to do, let's make sure that my standard PLA prints just as well with this nozzle and new Hotend as we were getting before on these test prints. So now that we've got our retraction settings set up, we're going to go ahead, let's print this stringing test, see if we get the same results. Well, that's the end of part 1. I hope you've enjoyed this part, and I hope you're looking forward to part 2, where I'm actually going to show you the test results of printing PLA with this Hotend, as well as the test results of printing several other high temp filaments with this Hotend. You're going to get to take a look at different materials, and then in part 3, possibly part 4, we're also going to take a look at different nozzles that you can use on this Hotend from Micro Swiss. Well, again, if you've enjoyed this video, please hit the like button. Please leave a comment. Let me know what you think. Should I have left this whole video together, or do you kind of like it broken up into pieces? As well as please share this video on other social media platforms. That helps the channel a ton, gets me some new viewers, and helps share this information with the larger community. Again, I am Chris, and this has been Kersey Fabrication. I'll see you in the next video.